Hello friends, welcome to Shibi's chemistry classes. Now today, this is the third video of first chapter of your class 10th ICSE chemistry, that is the periodic table, periodic properties and variation of properties. So in the first video we have studied about periodic table, and in the second video we have covered three periodic properties, and here we are going to cover the rest of the three properties that are ionization energy, electron affinity and electronegativity. So without wasting time, let's start with ionization energy. First we'll define it. The amount of energy needed to remove electron from a neutral isolated gaseous atom to convert it into a gaseous ion. Now let us try to understand what this definition is saying. Suppose this M is any element, XYZ anything. Now we are supplying it with ionization energy, and when we applied this ionization energy to it, it loses its valence shell electron and gets converted into a positively charged ion, gaseous ion. So here, for the removal of this valence shell electron, we are applying some energy. Some energy is required to remove that electron. So that energy is called ionization energy, and its unit, since it is energy, it has some unit, that is kg, kilojoule per mole. This is the unit of ionization energy. Let's take an example. Magnesium, atomic number 12, configuration 282. To attain a stable electronic configuration of 2,8, it has to remove this 2 electron from the valence shell. That means it is having 2 extra electron which it wants to remove. So for doing that, what we have to do? We have to supply it with energy. So that energy is called ionization energy, and after supplying this energy, this 2 electron get removed and gets converted into magnesium, a positively charged magnesium ion with 2 plus charges. Why? Because it has removed 2 electrons, so 2 protons are more than 2 electrons, so that is why it is having 2 plus charge. It depends upon 2 factors. Factors are same for all the periodic properties. What are the factors? Atomic size and nuclear charge. See, trends in these periodic properties we will see in another video. Okay, here we are discussing only the periodic properties. Atomic size, again we have discussed it many times, that an increase in the size of atom will favor the removal of electron easily. Why? Due to the lesser force of attraction between the nucleus and the outermost electron. So because of that, the electron gets removed easily. So if more is the atomic size, lesser will be the ionization energy. If more is the atomic size, lesser is the ionization energy, because the electron will be removed easily. And if more is the nuclear charge, greater is the nuclear pull on the electron. As a result, removal of electron will become difficult. So more the nuclear charge, more is the ionization energy. Means more is the atomic size, less is the ionization energy. More is the atomic size, lesser is the ionization energy, and here more is the nuclear charge, more is the ionization energy. Clear to everyone? Now next is electron affinity. Electron, number fifth, electron affinity. After completion of the chapter, we will discuss some questions that um, you got in your previous year question paper. So we will do some question also. We'll solve some questions. Now, electron affinity. The amount of energy, now here, the amount of energy released. Affinity means, affinity means इच्छा, इलेक्ट्रॉन को लेने की इच्छा है ना. So amount of energy released when an electron is added to a neutral, the amount of energy released when an electron is added to a neutral isolated gaseous atom the amount of energy released when an electron is added to a neutral isolated gaseous atom and gets converted into negatively charged gaseous ion. Suppose this is an atom of any element. What we are saying, electron is being added to this atom, and we know that non-metals have the tendency to accept electrons. So generally electron affinity we see in the case of non-metals, and ionization energy we see in the case of metals. Okay, so electron affinity is the amount of energy released, means when this atom accepts the electron, it releases some amount of energy, and that energy is called electron affinity. Means the more the electron affinity value, the more is the tendency of the atom to accept electron. We are adding electron to it. It is converted into a negatively charged gaseous ion, and electron affinity. Energy is released again kg per mole. kg per mole. So this is the electron affinity. We'll take an example, say chlorine 287 accepted one electron, converted into chloride ion with 288, and energy is released, and that energy is called electron affinity. So the more the value of electron affinity, the more is the tendency of that atom to accept the electron. Again, it depends upon two factors, nuclear charge and atomic size. Now how these two factors affect electron affinity, we'll see that. Atomic size, nuclear charge. If greater is the atomic size, Lesser is the force of attraction between nucleus and the outermost electron. And what will happen if there is less nuclear pull? Then electron will not be accepted easily. So what will happen if greater the size, lesser is the amount of electron affinity, and lesser is the tendency of element to accept electron. Greater the size, lesser the electron affinity. Smaller the size, more the electron affinity. Nuclear charge, greater the nuclear charge, greater electron affinity. Why? Because it will pull the electron towards itself. So it will accept electron easily. If nuclear charge is more, it will attract the electron towards itself. So the addition of electron will become easier. But that is not the case when nuclear charge is less. If nuclear charge is less, there will be no attraction, and the removal, it favors the removal of electron, not the acceptance. Okay, so the greater the nuclear charge, greater is the electron affinity. So it will become more clear when we see the trends in these properties. When we take examples from the periodic table, group wise and period wise, then these properties will be more clear to you. And the last one is electronegativity. See, electron affinity value is always in negative, because energy is released. So when we write electron affinity value, so we always used to write it in like just now we have taken the example of chlorine. So addition of electron in chlorine to form chloride ion, this much amount of energy is released, and kg per mole. So always we used to put a negative sign over here in the value of electron affinity. Next is electronegativity. Now it is the tendency of an atom. It is the tendency of an atom in a molecule to attract shared pair of electron towards itself. Now what is this? See, in electron affinity, what we have seen, that electron is getting added to that atom, but here electron is not getting added, it is only attracting the shared pair of electron. Shared pair means in chemical combination. In the next chapter you will get a clear picture of this electronegativity in the second chapter. So here just take example, suppose HCl molecule means the compound that is formed by the combination of two or more elements. They form molecule like HCl. We all know it is hydrochloric acid formed by the combination of hydrogen and chlorine. Hydrogen has one electron in its outer shell. Chlorine has 7 electrons. It is short of one electron to complete the octet, and hydrogen is short of one electron to complete the duplet. So what will happen? They will share the electron between them. Now chlorine, after sharing, now chlorine also has 8 electrons. Hydrogen has 2 electrons. Now both are satisfied with duplet and octet arrangement. But what we have to see is electronegativity in terms of, we'll take this example. Why we have taken this example? Just to get an idea of electronegativity. It is a tendency of an atom in a molecule. This is a molecule and these are the atom, to attract shared pair of electron towards itself. This is the shared pair of electron, and what happened to this shared pair? The atom which is having more electronegativity value, it will attract the shared pair of electron towards itself. So this is electronegativity. It doesn't has any unit. It is only measured in scales. We measure electronegativity in Pauling scale, and fluorine is the most electronegative element with a value of 4. Fluorine is the most electronegative, then oxygen, then nitrogen, and so on. So I think electronegativity is clear to you. अभी इतना ही आपको समझना है कि it is the tendency of an atom to attract the shared pair of electron. अब यहाँ पे chlorine being more electronegative than hydrogen, what will happen? These two electrons in this bond will be attracted a little bit more towards chlorine. So as a result, this chlorine will get a negative charge and hydrogen will get a positive charge. So this is electronegativity. Fine. So it is measured. It is a dimensionless quantity. What is it? Dimensionless, only measured in scale. That is called Pauling scale. Is the more widely accepted scale, and fluorine is the most electronegative element with a value of 4. So we have covered all the 6 periodic properties. Now in the next video we have to see the trends in periodic table, trends in these periodic properties. And after that we will do some questions. I hope you all are enjoying and things are getting clear to you. And if you have any doubts related to the videos, if I'm going fast or my writing is not clear, you can comment me. Till then, now I'll come with next video. Till then, bye bye.